Hello students, welcome to Young Cubs. Today we are going to start with the chapter called Materials and Their Structure. Children, what do you know about materials? In terms, what kind, where are they obtained from, what size are they available in, and how are all the materials, are all objects and substances made up of the same material? What is it that you know about? Okay, today we are going to discuss about materials, any kind of material, okay, right from its minutest form. Children, we all know that anything and everything on this earth is made up of tiny particles, okay. uh, if you see a log of wood, if you crush it and break it down and further break it down and till you break it down until it becomes microscopic, okay, that small is a particle of any materials, or even small, some particles are smaller than the others. Okay, so today when we talk about material and their structure, we are going to talk about them at the particle level. So what is the particle theory all about? First of all, children, we know all objects or matter or material, okay, have three states, or are in three forms: solid, liquid, and gaseous. Okay, even gases are made up of particles, we knew that, right? So let's just recap what we've learned in our earlier years. So, we know some properties about solids, that particles in a solid are arranged in a fixed pattern. Why is it so, children? Simply because every particle has this property of attracting another particle. So, if the particles are closely placed, okay, they have a force of attraction between them from all directions. Okay, and that's the reason why, that's the reason how they form a fixed pattern or a regular pattern. And this pattern makes a typical type of a structure. Okay, and this structure is known as lattice structure or lattice arrangement. So particles are arranged in a fixed pattern known as lattice arrangement. Okay, the particles are held together strongly and tightly packed together. That means there is very little space between two particles. Yes, so if I look over here, there is very little space in between the particles. Okay, and that's why it said that they are tightly packed. Okay, and they have a strong bonding, or there is strong attraction between each other. Hence, the particles can only vibrate, but uh, they cannot, slide over, or they just, if they are in a position, okay, they can only vibrate. Okay, they can only vibrate, but they can stay in, that is, being in the same position. They can move a little to and fro movement, but they cannot leave or they cannot break the bond between amongst themselves and move out. Such kind of particles, which are arranged in a regular pattern, which have strong bonding, which are tightly packed and have a regular arrangement, and they only have very little movement, that is to and fro movement, called vibration. Okay, such kind of particle arrangement is when particles are arranged in such a way, it is known as, they are known as solid. They are known as solid structures. Coming to liquids, the particles touch each other, okay, but when they vibrate too, but it so happens that their bonding is not so strong. So what happens is they can slide past each other, okay, they slide past each other, but they don't break. One doesn't go far from one another. They are still closer to each other, but they are all over, sliding and passing over each other, but it's not that they are far apart. When particles touch each other and there is some force of attraction, though weak as in weaker than the solids. Okay, these particles kind of move. They don't leave each other and go. They don't fly away from each other. Okay, these particles form liquids. These particles can move past one another and they can change their shape because they can slide past each other. They can take any form. Okay, basically they take form of the container. All right. Then gases. Gases are so far apart. They can drift away from each other in any direction. They have no sense of attraction towards each other. They just want to move away or fly away from each other. Okay, they do not touch each other. Okay, the particles spread out by themselves. The particles can spread out to fill up a space. So if I have a beaker, okay, if I have a beaker and if I pour some gas in it, just few particles of gas in it, they can drift away anywhere all over. Okay, so they have no shape, no form. They do not take the even the they can take the so they flow around or they drift about from where they are. They are free birds. Okay, they fly away, and hence gases can also change shape. All right. Then one property of liquids. Okay, let me talk in terms of all solid, liquids, and gases. Now, look at this picture, children. This solid cube. Basically, if once the beaker has been tilted, do you think it flowed down to the floor? No, it didn't. Right? It just gud just went down, rolling away. So does a solid flow? No, it doesn't. Yes, matter can only flow or be poured if the particles can move past one another. So if there are particles out here, okay, these particles have to flow past each other and move out. If they can do so, then only a matter or a substance can be poured out. So such pouring or pouring kind of a property exists only in liquids and gases. You can try this. You can take a sugar cube. Okay, you can fill a small glass with a lot of sugar cubes, big sugar cubes. Okay, and you can try tilting the glass, and you'll see they roll out. They roll out and fall. They don't flow in a continuous form. Yes, so but if you see in gases, okay, gases, if you open the lid or the cover of a glass, you will see them flowing out. That happens only because the particles pass over one another. They slide over one another. Matter can only change volume if the particle in it can spread out or move close together. So when particles are close together, you can find out the volume, the amount, the capacity of particles in a particular container or in a particular material. Okay, however, in solids you can find the volume. Okay, I'll show you how in further slides. But in gases, when the particles are not touching each other, each one is far apart. God knows where one particle is gone and where the other one has gone. Hence, the volume cannot be calculated, or their volume is not fixed. They fit into a small box as well as a big container. So there is no fixed volume of a gas. Understanding, children? So all in all, things can flow. Some things have a volume. So which ones can flow, which have a volume? Let's find out. So looking at solids, the particles are very close together. Correct? This makes it difficult for the volume of a liquid to be made smaller. So if the particles are already packed so close to each other, you think I can compress it further? I can press it and make it smaller in shape and size? No, it's not possible, because any which ways they're so close to each other that, see, the particles cannot even break. They can't even squeeze. Hence, the volume of a solid cannot be changed. Okay, solids does have a fixed volume because they are attractive forces. The intermolecular, or the forces between two particles is already so much. They're so close to each other. They attract each other so much that further pressing them down becomes impossible. Okay, these forces stop the particles from moving around. The particles can only vibrate. We know this. And since they are so close to each other, they attract each other so much. Because of this attraction, solids cannot flow. Alright, children. Coming to types of solids. This is where I want to bring to your notice that it's not that all solids cannot flow. Some solids can flow. Have you ever seen mama, cutting a packet of sugar and pouring it or making it flow down into a jar? How come this solid is flowing? But on the other hand, if there are big chunks of things or bigger things, or if something is too powdery, it falls in lumps. Yes, so some solids can flow. And which solids can flow? The crystalline, the grain solids can flow, like sugar, like tea powder, the tea, okay, like salt. They can flow easily from one container to another. But on the other hand, things that fall down in lumps, like wheat flour, any kind of flour, they if you try to make them flow from one container to the other, they fall in lumps and make the place around quite messy. Sand, okay, it falls in lumps. Yes, dry sand, I agree, is still flowy, but sand which has water, the attraction, the particles get stuck to each other with the help of water. At that time it becomes amorphous. Okay, so let's understand what is crystalline solid and what is amorphous solid. Crystalline solids have a highly order and repeating dimensional atomic structure. They are grainy, they are granular. So, granular solids flow. Okay, however, amorphous solids lack a long range order in their atomic structure. So, they are anyhow, they don't have a fixed structure. Okay, and have a disordered arrangement. So, anything having a regular arrangement and small grains will flow. Those kind of solids will flow. However, those that have a disorderly arrangement, a lumpy kind of an arrangement, they will not flow. Hope this much is clear, children. Now, coming back to fluidity and volume of liquids, we know that liquids, the particles in liquids, pass over each other, slide over each other. So, what happens is, if you tilt a jar or a glass, the particles in a liquid slide over each other and smoothly flow down. Yes, but however, remember one thing, whatever container that you take for a liquid, it takes the shape of the container, the liquid takes the shape of a container, correct? However, the shape may change, but its volume will not change. The volume of a liquid will not change. The number of particles, okay, in a particular area do not change. All right. Okay. So the volume of liquid cannot be changed. Okay. The attractive forces between the particles are weak. Even though they are weak, they are still sticking to each other, right? So they are not drifting away where volume cannot be calculated. Okay. To allow them to move, but strong enough to hold them together. Understanding, children, though the strongest intermolecular spaces, the strongest forces of attraction between particles will not allow it to flow. However, weaker ones, okay, allow them to flow. They don't change in volume because yet they are clinging to each other. Coming to gases, particles in a gas are a long way apart, so they can move away quickly in all directions. So, which all particles will you gather and try to calculate their volume? The particles can move easily because there are no attractive forces of between them. This means that the gas has no fixed shape or volume. Okay. Did you know, children, that if there is an empty space and if there are no particles in that, if there are just no particles in them, that means the place is a vacuum. There are no air particles, no water particles, no any kind, no solid particles. If there are space where there are no particles at all is called a vacuum. A vacuum contains nothing. Okay. Now, this is a gist of all the properties of solid, liquids, and gases. Let's take a look at it. Okay, volume. Volume means the capacity or how many particles of something can fix into or fit into a container, or can be fit into a particular space. Okay, so solids have a fixed volume. Solids have a fixed volume. Liquids also have a fixed volume, but gases have no fixed volume. They drift away. Shape. They have a fixed Now, so the shape of solids is fixed. Remember, I told you they have a lattice arrangement. Yes, children. Okay, volumes do not have a fixed shape, but they take the shape of the container, and gases do not even take the shape of a container. They just spread out all over the space that is provided to them. Intermolecular spaces. Intermolecular spaces means the space between two molecules. Okay, the space. If this is a pattern of molecules. Do you see this space? This is the intermolecular space or interparticle space. Okay, it is the least. They are so stuck. The particles are so stuck to each other that the space between them, intermolecular space between them, is the least. Whereas it is comparatively less as compared to gases, but it is more as compared to solids. So if solids have no space, liquids have a little space between them. Quite a little space they have between them. Okay, and gases, as you know, they drift away, so there's a lot of space between them. Okay, they have maximum intermolecular spaces. Okay, then coming to intermolecular forces of attraction. Forces of attraction, the particles in a solid have a lot of attraction, and that's the reason why they cling so strongly to each other compared to when it comes to liquids as compared to solids. They don't cling so hard to each other. They touch each other, but the clinging is not too hard. And when it comes to gases, there are no forces of attraction in them. Okay, coming to movement of molecules, they can only vibrate or move around their main position, to and fro, up and down. That's it. They cannot leave each other, or even, in fact, they can leave their structure. Okay, molecules continuously move, pass, and slide each other. Yes, they move past and slide over each other in liquids. And in gases, molecules move away in random direction. They are not touching each other at all. There is no force of attraction between them. Coming to fluidity, since they don't pass over each other, they don't flow. Liquids can flow and gases can also flow. Coming to compressibility, compressibility comes from the word pressing. When the solids, there is no compressibility. They cannot be pressed and fit into a space. Okay, liquids slightly compressible, and gases, obviously, they're so far apart that they cannot be compressed. They can be highly compressed. All the particles can be gathered together and compressed and come into each other. Okay, diffusion. But diffusion basically means to move away, to spread out. Okay, diffusion means to spread out. So, solids do not spread out. Liquids have a slight diffusibility, and gases have high diffusibility. All right. So, and then this is a diagram how a solid looks, how a liquid particle looks, and how the gaseous particles look. Children, solid, liquid, and gas are the three forms of matter or the three states of matter. But I hope you know, in fact, I'm sure you know that in the earlier standards as well, we've done the interchangeability of them. A solid can turn into a liquid, and a liquid in turn a gas, and a gas in turn to a liquid, and a liquid in turn back to a solid. And the processes, okay, have been given specific names. For example, when a solid changes to a liquid, The process is known as melting. Yes, when a liquid changes to a gas, it is either known as boiling or evaporation. Depends. I'll show you what the difference is between them. And gases, in turn, go back to a liquid state. It is known as condensation. And when a liquid goes back to a solid, it is known as freezing or solidification. So these are the processes where the state of matter changes. Let's go through these terminologies once again. Some of them may be absolutely new to you, and some of them will be, they will for you, it will just be a recap. So, if you leave ice cream in a warm place, it melts and becomes liquid water. It melts. The temperature at which a solid melts. So, for example, I have an ice cube, okay, and this ice cube, do we know at what temperature the ice melts and becomes a liquid? At what temperature does ice melt and become a liquid? It melts at 0 degrees Celsius. Okay, so the fixed temperature at which a solid becomes liquid is known as the melting point. So the melting point of ice is 0 degree. Melting point, children, is equal to the freezing point. So if ice melts to water at 0 degrees, at 0 degrees itself, the water freezes to ice. Hence, the melting point and the freezing point of water is the same. Yes, the water on the ground will gradually disappear as it changes from water to water vapor. Water vapor is nothing but an invisible gas. It is called evaporation. Yes, when water changes to water vapor. What is this process known as? Evaporation. And at the same time, when water, okay, changes to steam, it is known as boiling. What is the boiling point of water, children? The boiling point of water as is 100 degrees Celsius. But when it comes to evaporation of water to water vapor, there is no fixed temperature at which water evaporates. It all depends on the humidity and the wind speed and things like that. Right? So, coming to boiling, to steam. Okay, if water boils, the boiling point of water is 100 degrees. If the temperature, the fixed temperature at which water boils, which is 100 degrees, what is the condensation point of condensation of water or condensation of steam? So boiling point, boiling point. What is wrong? So boiling point is equal to point of condensation or point of evaporation is equal to the point of condensation. Hope this much is clear, children. Okay, it's whenever the word point is used with the process name, It means the exact temperature at which it is changing its state from solid to liquid or liquid to gas. If you put, where were we? So if you heat water until its temperature reaches 100 degrees, it will boil. All of the water rapidly changes to steam. Steam is water heated to a point that it turns into a gas. 100 degrees is the boiling point of water. If the water vapor or steam touches something cold, that means that the moment it has got in touch with something cold, okay, the temperature has decreased, the temperature of the particles has decreased, and that's how it, comes back to it comes back to water again. So it condenses and changes back to liquid water. Now this is known as condensation. If you put liquid water in the freezer, it freezes and becomes ice. These changes are known as changes of state. Correct? Now, let's understand the difference between boiling and evaporation. Okay, what is evaporation? Evaporation is a normal process. What do you understand by normal? It is a natural process. It naturally occurs in the environment, that occurs when the liquid form changes into gaseous form while causing an increase in pressure or temperature. Okay, so the temperature or the surrounding, when evaporation occurs, the surrounding temperature falls down, it becomes cooler. What is boiling? Boiling is an unnatural process. We heat the water, we put a flame under the water where the liquid gets heated up and vaporized due to continuous heating of the liquid. Okay, here no external heat. Here there is a supply of external heat. Correct? Now evaporation usually occurs on the heated liquid surface. So if this is a container and this container is filled with water, evaporation will occur only at the surface. Okay, the whole container is filled with water molecules, children. Yes, but evaporation will not occur for the underlying molecules. It will occur only on the top, because the uppermost layer or the surface layer comes in contact with the heat of the atmosphere. They get active and they move out as water vapor. Okay, and a fresh layer is then exposed as the surface to the surface. Boiling usually occurs on the entire mass. So if I have this container, I have water in it, okay, boiling will occur in the entire liquid. Okay, it goes, it's a cycle, it's a circular process. Okay, the one that is in direct, the particles that are in direct contact with the flame, okay, they heat up first and then they rise up, then the fresh layer goes down. So all in all, the whole liquid eventually boils. The boiling process occurs to in the entire liquid. Bubbling effect not visible in evaporation, whereas bubbling effect is visible in boiling. Okay, the process of evaporation is slow. Okay, whereas boiling is much quicker. Within 5 minutes, the entire water can disappear. But for water to disappear through the process of evaporation, it may take 2 or 3 days on a hot day. Yeah, hope you guys have understood the difference between boiling and evaporation. Sorry about the spelling, children. Typing error. Okay, now Let's look at this. This is ice. Yes, when it melts at room temperature, this process is known as melting. It turns to water. Water, when you boil it, okay, when I put heat below it, okay, when I put heat below it, it starts boiling. When once it starts boiling, it turns into steam. Okay, the melting point of ice is 0 degrees Celsius and the boiling point of water is 100 degrees Celsius. At the same time, when the steam comes in contact with a cool surface, it starts condensing. Okay, and when this water is kept in low temperatures in a refrigerator, okay, the process, it turns into ice. The particles, come close to each other, okay, and they become a solid. Okay, now when we are speaking about volume and fluidity, okay, I also wanted to teach you how do you measure liquid the volume of various different materials or various different what do you call it, solids or liquids. Okay, so when it a solid is has a regular shape, so if I have, say, so if I have a block, okay, a block of wood, okay, how will I find the volume of it? Simple, by the formula length into breadth into height. This is the length, this part is the breadth, and how tall is the dabba? It's the height. Okay, so if it's a regular object, okay, by the basic formulas, okay, for example, if you it would have been a cube, you have to apply the formula of a cube. If it would have been a cone, the formula of a cone. Okay. When it comes to irregular solids, you use the my method. No, it's not my method. It's by method of displacement of water. So what you do is you take a measuring cylinder. Okay. This is how a measuring cylinder looks. Children, have you been to a laboratory? Okay, there are calibrations on this. Okay, you say this is, okay, 10 ml of water. Okay, you know it is 10 ml. What you do is then take a string, attach the irregular object to it. Okay, this is quite oval. Okay, let me really make it irregular. Okay, let try tie this irregular object to the string and then dip the string into the water. What will happen? There will be the water level will rise. Say it comes up to, say, 20 ml. Okay, so 20 minus 10 gives you 10 ml. This 10 ml will be the volume of this irregular object. Alright, so understood how irregular solids, how their volume can be found out by displacement of water. Okay, and in liquids, how do you find the volume? By using a measuring cylinder. You straight away pour the liquid in a measuring cylinder. It's calibrated. Look at the where on what marking is the liquid at, and that is your volume. Okay, but there is one small catch to this whole thing. So when you pour water, or did you know, when water settles in any container, it kind of settles, it doesn't settle straight. No, it has a slight dip in it like this. Okay, this dip, the lowest point of the dip is known as meniscus. Okay, it is known as meniscus. Okay, when you measure water or liquid in a measuring jar, you have to make sure, first of all, your eye level has to be at, no, your eye should be at the level of the liquid, and you have to check the lower meniscus, the lower dipping point of your measurement. Okay, so using a measuring cylinder, you measure liquids. The liquid forms a curve at the top over here. There's a curve. Okay, this is called the meniscus. You measure the liquid for the bottom or from the bottom of the meniscus. To do this, you must make sure that your eye is in level with the meniscus. Okay. However, when it comes to mercury, children, for mercury, it has a higher meniscus, so it takes it's something like that. So mercury has to be measured from the highest tip. When it comes to water has to be measured from the lowest tip. Okay, here you go. So final volume, how is an irregular solid measured? First, see, this is 10, 15, and 19 ml. Okay, the moment the irregular object is thoroughly placed in, the water level rises. Yes, children, from here, from 19, it has risen to 29. So 29 minus 19, 29 minus 19, okay, 10 ml, 10 cubic centimeter. 10 ml is the volume, or yes, 10 ml is the difference. So 10 cubic centimeter will be the volume of this irregular object. Otherwise, for regular objects, here you have the length, you have the width, and you have the height, how tall it is. Okay. Now, coming to measuring temperature. You measure temperature simply with a thermometer only. There's no other way to measure temperature. But again, as I told you, mercury, has a higher mount kind of a thing. So the highest point has to be in eye level. Okay, here it is 25. It is not 24, it is 25. Understanding, children? So that's how a temperature has to be read. Okay, when you measure the temperature, you use a thermometer. The liquid in the thermometer is nothing but mercury. Okay, which has a mount kind of a thing. It expands. So when it is kept under the armpit or in the mouth, okay, the temperature rises. Your body temperature is higher than the room temperature. So what happens is mercury expands when the temperature rises, so it will rise up. Okay, and you read the temperature from the scale. Make sure that your eye is level with the top of the liquid in the thermometer. Check the upper meniscus. Okay, now explaining changes in the state of matter. Okay, when you heat a liquid, okay, these when you heat a solid, these solid particles feel hot, they become active. Okay, and that's how the attraction between them, they feel hot, so they don't want to cling to each other, they want to separate out. Please move away, I'm feeling very hot. Okay, so that's how they expand, and then the forces of attraction are broken, and not broken, but they become weak, and then eventually when it becomes weak, they turn into a liquid state where their particles slide over each other. They don't remain as strong as they previously were. Okay, so when solids are heated, they expand. The particles in solids are arranged in a fixed pattern. The particles are held together strongly and are tightly packed. We knew that, but the particles in the solid vibrate. When the solid is heated, heat energy is transferred to these particles in the solid, and that's how the more the energy the particles have, the more they start vibrating vigorously, and then they take up more space, so the intermolecular spaces increase and the intermolecular forces of attraction become less. The particles are still held together in position by attractive forces between them, but not as previously, and that's how they turn into a liquid. Now, that's how melting occurs. Now, each solid has a melting point. What does that mean? Each solid has a specific temperature at which, the bonds become weak. The intermolecular forces of attraction become weak, and that's when it turns into a liquid. When solids are heated more strongly, they melt and become a liquid. The particles in a solid vibrate more and more as heat energy is transferred to them. The particles vibrate so much that the attractive forces between them are not strong enough to hold them in fixed pattern. The particles can slide past one another and they can now move, not just vibrate. So now they are in a position to move and slide over each other rather than just moving from in their mean position. The forces are still strong enough for the particles to stay in touch with each other, hence a liquid. When even this when even this falls short, as in if once even this is broken, the further the molecular forces of attraction further weaken, then they start drifting away from each other and convert into a gas. The more the liquid is heated, the more energy is transferred to the particles, and the more particles will vibrate and move away. Okay. What about boiling liquids? As I told you, furthermore, heat transferred to the liquid particles, the further the forces of attraction weaken. Okay, now if they are so weak, eventually at the boiling point, they're so weak that they move away, and there's no attraction left between them, and they drift away or fly away in the form of gases. Okay, now some particles have enough energy to break the weak attractive forces holding them together. These particles can move freely and escape as gas particles. Contrary to boiling and heating and transferring heat to particles is the cooling process. Now, when particles are in gaseous form, children, remember, they have a lot of energy in them and they are highly active. Okay, when these particles start losing heat, that means they are becoming less active. And when they become less active, they settle down or they start coming closer to each other. When they start coming closer to each other, that means they are condensing, and they are condensing to become and coming closer to become liquids. So when they come close to each other, these spaces, the intermolecular spaces, are reducing, and again there are bonds being formed between them. What are these bonds? The intermolecular forces of attraction is getting established in them again, and that's how these gases now settle down, become less active, there are less spaces in them, and there is some kind of attraction between them, and that's how gases turn into liquids. Look at this picture. This is a cold surface, something like a mirror in your bathroom. When you're taking a hot water bath, you see, there's a lot of steam being generated. Okay, and when the moment they come in touch with this cool surface of the mirror, what happens is they condense, and eventually when the temperature lowers, or you open the door, there is cool, little cooler air flowing into the bathroom. What happens is you see these gases apparently forming into water droplets on them. All right. So their movement slows down the moment they come in contact with a cooler surface, when they hit a cool surface. So let's read. The particle in a gas are free to move anywhere and they spread out. There is no force holding them. When a gas gets cooler, that means it will condense to form a liquid. When gas particles reach a cool surface, some of the heat energy from the particles transfers to the surface. Yes, the particles move less and get closer together and they form a liquid. Okay. Furthermore, how do these liquids freeze now to become solid? Same thing, they come further closer, establish more attraction. Okay, they are so close to each other that they convert into a solid, lowest compressibility and highest forces of attraction between them. Okay, when a liquid freezes, it becomes a solid. As heat energy is transformed from the particles to the surroundings, the particle become cooler and they move more slowly. They become less active. Okay, and the liquid gets cooler. When they become less active, they kind of come and cling to each other. The cooler the liquid, the less energy the particles have. Okay, the less energy the particles have, the less they are able to move or slide past each other. Okay, eventually the particles have so little energy and so little spaces between them that they cannot move and flow anymore. They can only vibrate in their main position, and thus their arrangement again comes into a fixed pattern. Okay, and they form solids. Well, that's all for today, children. Thank you and God bless you all.